everybody, today I'm going to show you steps for the proof that 1 plus sine x over cosine x is equal to cosine of x over 1 plus sine of negative x. Anytime you do a proof like this, what you want to do is start with one side and end up at the other side. We are only going to manipulate one side of our original equation and we should end up with the other. I'm going to start on the left with the 1 plus sine x over cosine x, and I'm going to explain each step of manipulation that I'm going to do until I arrive at cosine x over 1 plus sine of negative x. So we'll start out by isolating our 1 plus sine x over cosine x. And I want to remember that I'm somehow trying to get cosine x on top and I'm trying to get a sine x on the bottom. Getting cosine of x into the numerator is kind of easy to do. I could just multiply the top and bottom by cosine x. When I do this, notice I did cosine x over cosine x. I do that because this is equal to 1. When I multiply by 1, I don't change the value of anything. From here, I want to distribute the cosine of x. So I have 1 times cosine of x plus sine of x times cosine of x, and in the bottom I have cosine x times cosine x. At first this doesn't look much better, but I do notice I have cosine x times cosine x in the denominator, which I can write as cosine squared x. This is really great because it introduces an identity. We know that sine squared x plus cosine squared x is equal to 1. That's a Pythagorean identity. I can isolate the cosine squared x by moving the sine squared x over to the right. This says now that I have cosine squared x is equal to 1 minus sine squared x. This introduces the sine squared in the denominator, which was another goal we had. Let's put that in. Let's take a quick look at what we're trying to get. We're trying to get cosine x over 1 plus sine of negative x. I have sine x in the bottom, but I don't want to have sine squared. But maybe you notice the denominator is now a difference of squares. I have 1 squared minus sine squared. I can factor that out into 1 plus sine x times 1 minus sine x. This looks pretty good. I can see now I have a 1 minus sine x, which is close to what I want in my final step. But I need to get rid of the 1 plus sine x in the denominator. So let's take a look at the numerator and see if we can make it any smaller. I notice that I have a cosine x in both of my terms. Let's factor that out, which gives me cosine x times 1 plus sine x in the numerator. Now I have a factor of 1 plus sine x in both the numerator and denominator that I can cancel out. Now we're super close to being done. The only thing I need to do is somehow make this sine of x be a sine of negative x. But maybe you remember that sine is an odd function, meaning sine of negative x is the same as negative sine x. So I can take this negative sine x and replace it with sine of negative x. That simplifies to cosine x over 1 plus sine of negative x, which is exactly what we wanted to prove. Now that we've come up with the right side, we can stop. We took 1 plus sine x over cosine x, used identities and properties to come up with cosine x over 1 plus sine of negative x, which means we've proven that these two sides are equal.